When we talk about popular science, the idea that everyone deserves access to knowledge, that complex ideas should be understandable by all, and that through science and reason we can set aside our differences and build a better future, one name rises above almost all others in history: Carl Sagan.
From childhood, Sagan was captivated by science fiction. Books like Lest Darkness Fall and He Built a Crooked House ignited in him an incredible love for science and astronomy. He turned that passion into a career, making groundbreaking contributions to astronomy, astrophysics, and astrobiology. But he didn't stop at the boundaries of academia.
Through documentaries like Cosmos, through his books, and through his legendary public lectures, Sagan became the driving force behind making science popular worldwide. He inspired millions of children to fall in love with the universe. He was, in every sense, a giant.
I originally planned to mention him briefly, but when it comes to Carl Sagan, there's no such thing as brief. We'll talk more about him, but right now, I want to tell you about something else entirely. In the 1970s, Carl Sagan began writing a science fiction screenplay with Anne Druyan, the woman who would later become his wife and lifelong collaborator. By 1979, the film deal had fallen through, but Sagan and Druyan had poured too much of themselves into this story to let it die, so they made a decision. They would turn it into a novel. Publishers got their hands on the story, and they were electrified. Before a single copy had been printed, they paid Carl Sagan $2 million for the rights. $2 million for a book that didn't even exist yet.
The book was published in 1985. Within 2 years, it had sold nearly 2 million copies. Its name was Contact. The book captured the imagination of everyone who read it. Naturally, Hollywood came calling again. But tragically, Carl Sagan passed away in 1996. He never got to see the 1997 film adaptation, the one starring Jodie Foster, that would bring his vision to millions more. Now, books and films like Contact aren't exactly what we'd call typical science fiction. They belong to a genre known as hard science fiction, where the science isn't just a backdrop. Every scientific concept mentioned is rooted in real research, real theories, real physics. And Sagan, while writing the story about humanity's first contact with extraterrestrial life, hit a wall. He refused to take the easy way out. He didn't want to just make something up.
Quick, playful storytelling with building tension. Minor spoiler alert. In the story, the protagonist Ellie received plans from an extraterrestrial civilization to build an interstellar travel machine, a vehicle to meet them face to face. But there was a problem. Getting to the other side of the galaxy and back would take thousands of light years.
Sagan wanted this journey to have a real scientific foundation, so he picked up the phone and called one of the greatest physicists alive, Kip Thorne. He told Thorne his plan: send the character through a black hole. Kip Thorne immediately pushed back. You see, back then, and even today, there was a widespread belief that you could just dive into a black hole and pop out somewhere else, as if nothing happened.
Kip Thorne knew the laws of physics simply wouldn't allow it, and he didn't just say so. He wrote Sagan a letter, a very long letter. According to Sagan himself, that letter contained over 50 lines of equations explaining exactly why you can't enter a black hole and exit somewhere else. And then Thorne called Sagan back with an idea. Carl, you know what you need? A wormhole. Until that moment, science fiction hadn't really discovered wormholes. You could say this one phone call brought them into the cultural consciousness forever. Wormholes. We've covered them in detail before, but you know the most popular and simple explanation. Think of a sheet of paper as spacetime. Now fold that paper in half. The 2 points that were far apart, they're suddenly touching. The shortest distance between them isn't a straight line anymore. It's a fold through another dimension. Istanbul to New York in an instant. Sure, this explanation is massively oversimplified, as you've seen in countless movies, but the core logic holds. And the beauty is, you can scale this shortcut to any distance you want.
And this was exactly what Carl Sagan's protagonist needed.
But the contact film and this wormhole solution ignited something far beyond fiction. The scientific community itself was about to start taking wormholes seriously. But in Kip Thorne's mind, a different kind of light was turning on. He was thinking about something that had become almost taboo in physics. Something that serious scientists were practically embarrassed to even discuss. While Thorne was thinking about wormholes as shortcuts through space, a question suddenly hit him. What about time? Could wormholes be used not just to cross distances, but to travel through time itself?
A time machine? He went even further. He believed that traveling backward in time could actually be possible. He went so far as to say, and I quote, "Not to have thought of this would have been idiotic. It's so obvious."
So, let's first look at what exactly was going through Kip Thorne's mind. And then we'll talk about whether this wild idea could actually work.
Here's what he was thinking. Imagine you have a wormhole, a tunnel with 2 ends, an entrance and an exit. Inside this wormhole, time can be manipulated in 3 distinct ways. First, like a portal, you walk in one door and instantly walk out another. Anywhere in the universe, you've manipulated distance and by extension, time itself. Second, the journey itself might take time. Depending on the wormhole's composition, you could enter and emerge somewhere specific, but only after an incredibly long passage through the tunnel. And the third possibility, the truly mind-bending one. Brace yourself. You could enter the wormhole and come out the other end before you ever went in.
Yes, I'm talking about going backward in time, traveling to the past. Impossible, right?
At least that's what we think. But Kip Thorne says that with one small modification, we might just be able to pull it off.
How? Let's talk about that right now.
But we can't have this conversation without touching on the most confusing concept in all of physics, time. I'm not talking about understanding time. That's incredibly difficult. But we need to look at how it works again.
According to Newton, as you know, time was simple. A one-way river, flowing on its own, independent of everything, unstoppable. Some describe it as the thing that prevents everything in the universe from happening all at once, piling on top of each other in a single chaotic instant, a way to prevent absolute chaos. But then Albert Einstein came along with his special theory of relativity and turned everything upside down. He revealed that speed affects time. The faster you move, the more time slows down. And at a certain point, it stops entirely. And this wasn't just theory. We've confirmed it through countless experiments. The relationship between speed and time is real. It's measurable. It's physics. You know the twin paradox. One twin travels at near light speed and returns home. Thanks to what we call time dilation, the traveling twin comes back to find their sibling decades older, while they've barely aged at all. The fast one stays young.
Now, when you take this completely real, experimentally verified physical phenomenon and apply it to wormholes, that's when things get truly extraordinary.
And it's worth remembering this. Wormholes are also known as einsteinrosenbridges, named after Albert Einstein and Nathan Rosen, whose work first predicted that a kind of bridge could exist in spacetime, connecting a black hole to a white hole, a shortcut through the fabric of reality itself.
Now, the original theory doesn't mention time travel or going backward in time, but according to Kip Thorne and scientists who think like him, if you're a sufficiently advanced civilization, you could make it happen.
Here's what you'd need to do. Take one end of the wormhole and accelerate it through space at near light speed. Because of time dilation, a time difference begins to form between the entrance and the exit of the wormhole.
Now, bring that accelerated end back to Earth. What you have now is a wormhole, where one end exists in the future and the other in the past. More time has passed at the earthbound end, less time at the end that traveled. You've created a doorway to the past.
A door that, when you step through, takes you to yesterday.
So in theory, a sufficiently advanced civilization could turn a wormhole into a time machine and actually travel to the past.
But there's one obvious question hanging in the air. Where exactly are we going to find a wormhole?
Now, I know what you're thinking. Everything we've discussed so far sounds like pure science fiction, maybe even a little absurd. Honestly, I feel the same way every time I read about it. But look at who answers this question. Who tells us where to find a wormhole? John Wheeler, another groundbreaking name in the history of physics and science. Kip Thorne, John Wheeler, Carl Sagan. These are the extraordinary minds discussing this possibility.
So it's worth paying very close attention.
According to Wheeler, here's the situation. Space-time is like an ocean, and the fluctuations in space-time are like the waves on that ocean's surface.
But if you look at this ocean from an airplane, you can't see the waves at all, can you? From that height, the surface looks perfectly flat, smooth, featureless. But as you get closer, the waves appear, then the foam on the crests. And it's this foam, this chaotic, bubbling foam, that we can compare to what physicists call quantum foam.
At incredibly tiny scales, scales smaller than atoms, smaller than anything we can see, space itself loses its smoothness. It starts to bubble and churn. The ocean these subatomic particles swim in, that's quantum foam.
The dynamics of the particles within this ocean are still an active area of research, but here's the key. You can think of these tiny foam bubbles as incredibly small wormholes.
And despite being unimaginably small, a single cubic centimeter of this foam is believed to contain enough energy to evaporate every ocean on Earth. So, according to John Wheeler, what you need to do is capture this foam, extract it, and then expand it. Scale it up until you have a wormhole large enough to actually use. But there's another problem. The wormholes Einstein theorized about are open for an incredibly brief time, fractions of a fraction of a second. On their own, they have no practical use whatsoever.
Anything that tried to pass through would be instantly torn apart, down to its very quarks.
We need to find a way to keep it open. And once again, the answer comes from Einstein's own equations. Exotic matter, a substance with negative energy, and you need a lot of it. If you want to expand a wormhole wide enough for a human to pass through, you'd need millions, no, billions of times more exotic matter than we can currently produce in any laboratory on Earth. Yes, scientists have actually managed to produce exotic matter in a laboratory. That's real. But the amount, let's just say it's barely a trace, a whisper of what we'd need. What we need is a breakthrough,
a way to produce vastly more negative energy in far less time. And for that, we're going to have to wait. Probably a very long time.
So one way or another, just from the topics we've covered in this video alone, we could easily produce several science fiction films that would make everyone say, no way, that can't be real. In fact, alongside the documentary plans I already have in mind, I've got a few science fiction ideas of my own brewing. Who knows? Maybe one day I'll bring them to life.
But the bottom line is this. Once we overcome the many obstacles we've discussed, once we become that sufficiently advanced civilization we've been talking about from the beginning, a door to the past could become a reality of everyday life. But the moment that door opens, we'll have lit the fuse on countless paradoxes, like opening Pandora's box, inescapable loops, changing the past, violating the laws of physics, and possibly destroying everything.
But the mind-bending paradoxes that come with traveling to the past, let's save that for its own episode, shall we?
And as always,
Until we meet again, I'm so glad you're here. With love.